Hello, this question is from GATE 2013 from the domain of nuclear and particle physics. So the question is pretty long. So the question states the electromagnetic form factor f of q square of a nucleus is given by f of q square equals to exponential minus q square upon 2 capital Q square, where capital Q is a constant, and given that f of q square equals 4 pi upon q integration 0 to infinite r dr rho r sine qr and integration d cube r rho r equals to 1, where rho r is the charge density. The root mean square radius of the nucleus is given by, so we need to find the root mean square radius of the nucleus. So let us solve. Given that f of q square equals 4 pi upon q integration 0 to infinite r dr rho r sine qr. Okay. So this will be 4 pi upon q integration 0 to infinite r dr rho r, and we can expand sine x or sine qr as qr minus qr cube by 3 factorial plus qr to the power 5 by 5 factorial minus dot dot dot. Okay, let me just rewrite this part for more clarity. So it will be 4 pi integration. So 1 upon q and q, it will be cancelled. So integration 0 to infinite r square dr rho r minus, so it is q cube r cube, so it will be q square by 6 integration r to the power 4 dr rho r plus, so we neglect uh, and higher order terms. In that case, we will get f of q square equals 4 pi integration 0 to infinite r square dr rho r minus 4 pi q square upon 6 integration 0 to infinite r square times r square rho r dr. Now the value of r square is given as 4 pi integration r to the power 4 rho r dr. So from the three-dimensional spherical polar calculations, we can easily find out this thing. So f of q square will be 4 pi integration 0 to infinite r square dr rho r minus what I say as q square by 6 expectation value of r square. So this is independent of q, so I can just say it's as a constant k minus q square by 6 expectation value of r square, where k is independent of q square. So you can say r square, or if I just differentiate both sides, like is the f of q square, so df of q square by dq square would be minus 1 upon 6 expectation value of r square, and I need to calculate it around q equal to 0. So r square would be minus 6 times df q square by dq square about q equals to 0. Now again, given that f of q square equals to exponential minus q square by 2q square, put q prime equals to q square, then f of q prime equals e power minus q prime upon 2q square. So this implies f of q prime by dq prime is minus 1 upon 2q square e power minus q prime by 2q square. So this implies f of q square by dq square is nothing but 1 by 2q square e power minus q square by 2q square. So the value of this derivative, first order derivative, about q equal to 0 is minus 1 upon 2q square times 1. So it is minus 1 upon 2q square. So the expectation value of r square is minus 6 times this value, which is minus 1 by 2q square, and this will give me 3 upon q square. So we need to find, I think, the root mean square. Yeah, root mean square radius of the nucleus. So root mean square radius of the nucleus is given by root under expectation value of r square, which is root under 3 by q square, that is root 3 by q. So let me take the option. Option C would be the correct choice. Thank you.